Hi, Holly. Welcome back.
Thank you.
Now, the most important question. What is your favorite recipe?
Ooh, I do like a cheese fondue.
Cheese fondue? And is it that hard that you need a recipe for that?
Well, I suppose not actually, because you can mix the proportions, but I don't make it that often. So when I make it, I need to get out the recipe.
But cheese is just cheese, or you need something else?
Yeah. So it's cheese, but then you mix it with wine and garlic and a little bit of starch to sort of help it emulsify. Well.
I just saw this is just a cheese, so I was a little bit disappointed. So this is
no, I mean I do love cheese, but no, this is this is a fondue.
So that's cool because last time you mentioned you created a multiple cheese recipe management systems.
Yes.
So this is what I was curious what it's all about. And you are from UK, right?
No, I'm living in the UK, and I've been living in the UK for 25 years, but I'm originally from Toronto.
Super cool. So Canada.
Yeah.
And but UK, 25 years, so you have experience with UK because what happened to me once, I bought at the airport, in a fancy store in London, chocolate. And this was before Christmas, and I really looked forward to open that, and I opened the chocolate, and the strange thing is it was not brown; it was more like pink, and I think there were flowers inside the chocolate. This was like very famous English chocolate, roses or something, and it tastes not like chocolate. So I was completely disappointed about English chocolates, and since then I never even look at the chocolate if I'm in UK. You know what I actually bought? What? It was like a very specific Christmas something.
Oh, I mean, so I think there's something called Cadbury Roses. So
maybe
it might have been that. But there's I knew someone who used to work at this is one of those stories of I knew someone who knew someone who used to work at one of the chocolate factories in York. And what they would do there was they would make all the different chocolates for the different export markets, and they were all different. So he was sort of able to go on a tour of the factory and taste all the different chocolates. So I think the chocolate that was exported to North America had more salt in the recipe, and there was just all these sort of regional variations to accommodate the sort of various local tastes.
Okay, but mine was, I think, origin from UK, because in Germany I don't think we have chocolate with flowers or roses or whatever. And I asked someone from England, and he told me a long time ago what it was, but it was like delicious stuff in England, but it disappointed me a little bit because it tastes really strange, and the chocolate was like not really brown, like a rich. It's more like a little bit white, pink. So this was crazy taste, texture, everything. Okay.
Yeah, I mean you get a lot of milk chocolate here, so it's obviously not going to be as chocolatey as it.
Yeah. So you are not a chocolate expert?
Not really. I have this weird thing. I don't like chocolate that much. I like chocolate flavored things, so like chocolate cake, chocolate brownies. But if you give me just a piece of chocolate.
Yes, it's for me the same. But I just wanted to taste something new, and So now the warning to all listeners: before you buy in UK chocolate, you have to double check whether there are flowers or roses inside. Very good. About performance saving with Quarkus. Because it is also one of the reasons why I use Quarkus all the time and why I'm able to do 100% Java in the cloud. Because the first time in history I'm able to show or to prove to management, then we are able to save money with Java. And the cool story is, because we are saving money, we're also saving energy. So this is both. So this is actually pretty cool, which reminds me, in a web standard web component world back then, I tried to build accessible software, but I sold that to management as a software for power users, because if you have all the key bindings and so forth, it was actually great for both, for interestingly, for people with disabilities and as well as for power users, because you can control everything without having a mouse Okay, cool. So why you started with how to call it, sustainability? No, power efficiency. Why you had interests in this area? Why you got interests?
I mean, it's a good question. It's something I've been interested in for a while. And I started thinking about it when I was working a lot with Kubernetes, actually, because we had gone from a system where we were still in the cloud, but we would deploy like a single artifact, and it would be on a centralized control plane that wasn't Kubernetes. And then we switched to Kubernetes, and I realized that the way we were using it and the way every organization seemed to be using it was that instead of having the pod be the unit of deployment, the cluster was the unit of deployment. And so then there's so much overhead that goes with every deployment. And I thought, is this right? Are we sure that this is what we want to be doing? And then when I looked at it more, because I was a consultant at the time and I was working with clients, and I realized that it's worse than that, because it's not just that you deploy the cluster and then you get a lot of value out of the cluster. What happens is you deploy the cluster and then the business priorities change, and then that thing might not even be used at all. It might never make it to production, but it still doesn't get decommissioned, or it might be used for a year and then it stays running. And so then and I started to look around, and as an industry, we have so much waste that comes just from these deployments that have too much overhead for the amount of content in the deployment, and also from these zombie deployments where software just gets forgotten. So that was sort of already on my mind. And then I joined the Quarkus team. And as you say, one of the real strengths of Quarkus is it's got this incredible performance, and it's got this incredible deployment density. And so then I asked the question of, well, if we're really small and we're really fast and we're really light, does that mean we're more sustainable? And my new colleagues sort of said, well, we think so, we hope so, but we don't actually we've never done the measurements to confirm that. So I started, I was going to say I started doing the measurements, and actually we were working in a team, so I didn't actually do any of the measurements. Instead, I sort of annoyed my colleagues until some of my colleagues did measurements. And I also took some of the measurements that had already been done and extended them to be able to confirm exactly that when you deploy Quarkus, if you're replacing your Spring Boot installation with a Quarkus installation, you're probably going to reduce your costs by maybe 2/3, and you're going to reduce your carbon footprint by maybe 1/2. So it's this really significant saving. It's not like 5 or 10%. It's an well, not in order of magnitude.
The Spring Boot story is interesting one, because I absolutely get why someone still uses Spring Boot on OpenShift, whatever, because if they have already a huge footprint of Spring Boot and experience, understandable that the next project is Spring Boot. But what's a little bit strange is that Spring Boot is sometimes used also in serverless, where there's this complete different, I would say, context, because you're usually starting from scratch. This is complete different environment. You cannot reuse lots of stuff, and it has huge downsides actually. And I actually had also a chat with AWS why they even have examples of promoting that, because if you start with Spring Boot, it's just the cold start and everything is way worse than with Quarkus or Micronaut or whatever. They could even, I forgot, there's little frameworks without anything, just HTTP server, like the Java web server. There are lots of small things, maybe even this, if they don't like Quarkus or Micronaut, but Spring Boot was the same as I would use, the old Glassfish as a Lambda. Okay, it would work, but why? And there was basically no answer. I think this is like, cargo cult, okay, because it was like it was. Another story regarding your reports. Can I steal some results from your report? Because what I do on my conferences, on my talks, there is one slide I usually always have in Java-related talks, and there is a study, energy efficiency languages, which compares languages to Java, and from energy perspective, it looks like C, Rust, C++, Ada, and Java. and then Pascal is after Java, and then is Lisp and whatever, Fortran, and everything is actually consumes more energy than Java, which was really surprising. And then there is CPU. This is the performance. So there's energy and performance, and they're almost identical. So there's the same C, Rust, C++, ADA, and Java. And in both cases, like, TypeScript and Python are 35 times worse than Java. That's the interesting part. And this is how I get the projects, by the way, because I said, we can do this, but with Java, we can save lots of energy and money. And what doesn't look that nice is the memory consumption of Java. So Pascal is first, and Java is 6 times worse. And by the way, energy efficiency in CPU, Go is worse than Java, which surprised me, I have to say.
Yeah, it surprised me as well, because there's sort of this. I mean, the internet has a really long memory, and everybody. Well, we have to have intuition, otherwise we can't function. And so it's just such a natural intuition to say, well, of course, a compiled language is going to be faster and more energy efficient than an interpreted language like Java. And I've got interpreted in quotes because, of course, Java isn't interpreted in most cases, and that's what makes it so fast.
And regarding the memory, Java is 6 times worse without Graal or Mandrel, right? So if we compile Java with Mandrel or Graal VM, so there are no numbers, but it is really small. It's hard to tell, but I would say comparable maybe to Fortran, Go, whatever you have. I cannot imagine it's significantly bigger than that RAM consumption.
Yeah, I mean, we see it's about a tenth of the memory when you go to native.
Yeah.
So then that's comparable. Yeah.
So what it means is actually Java is the absolute mainstream cloud language, if you just go to the numbers now. And you have some numbers from Quarkus, which interest me because I don't have these. Are they published? So can I just steal from your presentation?
Yep. So they're available in that presentation. They're also published if you search for writing greener Java applications, you'll find a white paper from a couple of years ago that has those numbers in them. But I do have an update as well. So this is sort of hot off the press, kind of bleeding edge, so it's sort of, we haven't formally launched it yet, but we're in the process of refreshing those numbers. And as well as with the numbers, what we really wanted to do was provide the link to the source code and the link to the reproduction steps, and also a range of reproduction steps, because one of the challenges with a lot of benchmarks is you have to run them in such a controlled environment in order to get valid results. But none of us have those controlled environments, and so then you sort of end up with this situation where you have it's almost like an appeal to authority, logical fallacy, where someone says, "Oh, I'm so much faster and I've measured it, but you're not allowed to measure it," which is just not right? Like everybody should have access to this. So we have a new repository in the Quarkus.io GitHub org, and it's called, I think, something like Spring Quarkus Perf Comparison. And that has our benchmark code. And so we've got an application which is intended to be the exact same behavior, the exact same function, and we've got a Spring version of it, and we've got a Quarkus version of it. And we also have what's possibly my favorite one, because if you look at the Spring code and the Quarkus code, it's really pretty similar. But there's a few differences. But then we have one which is, we take the Spring code and then we just, in the POM, replace the Spring dependencies with Quarkus compatibility shims.
That's cool.
So the programming model is exactly the same. The application is exactly the same, but the dependencies are different. And then it, goes twice as fast or 3 times as fast or however much it is. And so then what that shows you is, it's not the programming model that is the problem. It's the dependencies in the architecture. And so if you change those, you get the speed up. And so we've also got, if you go to GitHub and then in the Quarkus.io org, there's a repository called Benchmarks, and that's where we're publishing all of our results. And so then the next thing that we're going to do is we're going to start having the sort of the more curated set of those results from, on the release boundaries and with some interpretation and that kind of thing. And as well, we're measuring like 10 variants or that kind of thing. Or actually, I think we're measuring 16 variants. So then you end up with this chart that has 16 things on it, which is too much. So we're going to have subsets of the charts. So all of that is still sort of still in progress, but people can see the results. And it's really exciting because it's all public. What it means is now we're starting to have people looking at the repositories and saying, oh, well, this pattern isn't actually the optimum pattern for Spring. If you do this, it will go faster. And so then we can do it and we can see that, yeah, maybe it goes faster, maybe it doesn't. Because one of the things about performance is, of course, it's very easy to guess a solution. And sometimes when you measure isn't actually what you expected. So, because we really want it to be a community effort and a collaborative effort to get those numbers.
This is perfect because now it's competition between Spring Boot and Quarkus, and in the end, everyone wins because everything gets faster. Yeah. And maybe even Java, so I can update my first. Maybe Java will be not in the number 5 right now, but number 4. Maybe we can kill Ada in one of time, be faster than Ada, And this is also what management loves. They love numbers, So I can pick that and say, this is the reason why I use Quarkus, period. So we could use, because, at the end of the day, it has to be productive, it has to be maintainable, and it has to be cost efficient. And I think in all 3 cases, Quarkus is golden because maintainable and productivity, everyone loves Quarkus. What I completely underestimated, because for me it was normal, is how highly appreciated this Quarkus dev experience is.
Yes.
Recently on the podcast, I also had a Stan say, try it, and he also loved the Quarkus dev. For me, so yeah, okay, because it starts fast, but people like it. And it seems like Spring doesn't have something similar, or maybe it works differently. I have to admit, I have no experience with Spring. Never used that. I helped only in one project in a task force, but Spring was not the problem. It was from the architecture. But it seems like they really appreciate the Quarkus dev experience, which amazed me because Quarkus is a way newer than Spring, right? And Spring was always told to be lightweight and better than Whitefly and Glassfish. And even on Glassfish or Whitefly, the auto deploy on local machine worked perfectly for me. Quarkus is better, but it was good enough. And so this surprised me. And now, this is like more numbers. The more numbers we have, the better it is, right?
Yeah. And one of the things with this new work that I'm really happy about is, for the longest time, if you go to the Quarkus.io front page, we have a picture that shows we have better memory usage. We have a picture that shows we have better startup time. And we don't have a picture that shows our throughput. And classically in computer science, right, it's always a trade-off of like, yes, you can start faster, but you can have worse throughput. And that's the GraalVM trade-off. Or, you can have less memory consumption, but you run slower, which is also sort of the GraalVM trade-off. And so I think a lot of people kind of assumed that Quarkus wasn't that great on throughput, or otherwise we would be talking about it. But actually the reason we weren't talking about it was just that we kind of forgot to mention it so soon, because the thing is, our throughput, I think our throughput is actually probably where we have the biggest difference. And so that's why you see the higher deployment density and the greater energy efficiency. It's because of that huge throughput win that you get with Quarkus. And so you still see, like just the other week, someone wrote a sort of a Quarkus versus Spring summary article, and they, compared various benefits, and they didn't mention the throughput, which is because it's fair enough, right? Because we don't mention it on our website. So I'm hoping that we're going to fix that. Yeah,
you have to do that because what happened to me, so I had already lots of Quarkus clients, and they assumed that the throughput was not good enough. Yeah, and they always ask me about the reactive programming, Mutiny. It's like, why you would like to do Mutiny? Just write simple Java code. What about the throughput? And then we measured, and it was orders of magnitude always faster than the peak demand they had. So it means it was absolute pointless to do any reactive work in my projects. We just wrote, the simplest possible Java code you can imagine, and Quarkus just outperformed any requirements. Of course, if the database was slow, but from Quarkus perspective, it just worked perfectly so far.
Yeah, I think we sort of again, I think we made a mistake not talking about the throughput earlier. And I think another mistake that we maybe made was talking a bit too much about reactive. Because when we launched, there was a lot of excitement about reactive. And so we talked a lot about reactive.
Were you excited about reactive?
No.
Me as well. I hated that. It's like, why are you doing this, right? So this
it hurts my head.
Yeah.
I want a simple programming model. Yeah. But I think because a lot of the people in the Quarkus team had come from a reactive background, it didn't hurt their head. And they were like, oh yes, this makes a lot of sense.
Yeah.
And that's a really good thing for users of Quarkus, because it means the Quarkus, one of the reasons Quarkus does have that scalability is it's built on Vertex and Vertex. So it's got this sort of reactive core.
Yeah.
So it means you can use your blocking APIs like a normal person. But then as soon as it hits the Quarkus engine, it's sort of got the scalability of reactive. But I think people sometimes didn't realize that was an option, and they thought they had to use reactive in order to get the speed up. It's like, no, you could just use normal programming and it's still got the reactive core, because other people who aren't you are dealing with the headache of reactive.
Similar discussion to last time OSGI. So I have no problem with OSGI. If I don't see this, I'm happy. Yeah. So you can use OSGI inside, whatever you like, but I don't like to deal with the next. I remember now, what I really hated was the manifest. Because it had a specific format. It was impossible to write it without tool. The dependency, remember? This was like, in OSGI. I look at this, it's like, okay, come on, this is really strange. But okay, and reactive the same. Vertex is great, and I absolutely understand Vertex has to be reactive. But as application developer, I don't care, And pretty cool. So, and the throughput from Quarkus, I remember back then, is like Quarkus with Hibernate. I remember roughly 15,000 transactions per second. And if you do it in reactive on Hibernate, reactive is like twice as much. So it's an incredible amount of throughput with a single Quarkus you can get. So this is amazing story. Another question I wanted to ask you, because something doesn't make sense for me with Quarkus is the build system. So Quarkus does a lot during a build time, but the build is still faster than, I would say, regular application server deployment. You know what I mean? So if I would compare, deploy something to JBoss and run similar or build the same application or Quarkus is faster, but it does more actually than JBoss did before. I mean, why? It's just about optimization or something completely different what you did inside? You know what I mean? But I would expect to be Quarkus built Maven package with Quarkus a lot slower than Maven package plus deployment on JBoss, because it's the same story basically.
Yeah, and I mean it is a good question, and I was thinking about this last week as well. Of there is a trade-off, and if you move more of the work to build time, you expect slower builds, but with Quarkus, like that trade-off is really pretty small, and your build time is only a tiny bit bigger, or if you count in the deploy stage as well, then it's not bigger at all. And it is a good question. I don't know what the magic is there, because work is definitely being done. There's a lot of annotation processing and that kind of thing. And I know that we did do a bit of work recently. So it's I think in 332 there's some, or maybe it's in 331. Certainly in one of our recent or upcoming releases, we've done a lot of profiling work to get that build time that's really pretty okay, and get it even faster, because we were seeing with very large projects, it did start to be, you would wish it would be faster. But yeah, I honestly don't know what the magic is there to do so much work with so little cost.
Francesco Nigro?
Yes.
You have to give him this task, so then we get negative time, negative build time.
I mean, the improvements he's able to make, because, I used to work as a performance engineer, and, if you would get 5%, you would be like a hero. And, he just sort of turns up at work on Monday and goes, I've just saved 40% off this. It's like, what? No, that's not allowed.
But he's also a cool guy. He's a basketball, a break dancer.
Yes.
This is crazy. This is what I really appreciate, because he's so into this. And why he is so good? Because he's able to optimize from assembly, up to JVM, all the stacks. So he's crazy, actually. This guy is gold.
Yeah, and I love as well because he's very community minded. Because he's part of the Quarkus team. Red Hat used to pay his salary, now IBM pay his salary. But when he finds a performance problem, he will just go. And so he's done a ton of work in the Netty stack to optimize that, which Quarkus benefits from because our stack sort of has Netty somewhere at the bottom of it. But he'll be working in things that aren't the Quarkus stack at all, and he'll just be like, right, I'm going to go raise a PR and explain to this team why their performance could be better. And we're like, oh, okay.
I think the build performance, I get lots of questions. Why I ask you as well is latest air hacks. There's like a streaming show I do once a month. Someone asked me Quarkus in big projects, whether there are any performance problems with build. And I never heard about that, never encountered that. And my projects are fairly big, I would say. And what I assume is that sometimes the problem is hibernate with prepared statements or something, It's not that Quarkus is slow, but they have so many named queries. Yeah. This was the same problem I had with Glassfish back then. So it's not the fault of Glassfish. The problem was the database had to parse all the queries at startup, and in Quarkus would be at build time, maybe something there. What would be also cool is to compare Spring Boot build and deployment with Quarkus.
Yes, we do. That's one of the things that we're doing now, actually. So we have those numbers on the Quarkus.io/benchmarks site, and I think so. Quarkus is slower on the build time than Spring. So that's the only chart where Quarkus is.
Has to be, right? Because this will be complete magic, because I assume Spring does the same what JBoss does, just compile stuff, and Quarkus, in worst case, it reads XML and generates bytecode, highly optimized bytecode with extension for Hibernate, right?
Yeah. Yeah, and everywhere that you've got reflection, it's ripping out that reflection and sort of doing it in advance, so you only have to do it once. And I think I could look it up, but I think it's maybe 20% slower than Spring, maybe 30%. So it's that, it's a little bit slower, but it's only a little bit slower considering. Yeah. As I said, Guillaume Smet has done a ton of work recently with.
But this numbers would be cool, not faster. Because I get the question all the time. I can say, okay, now build time in Quarkus is 20% slower than Spring, and everyone is satisfied. Be some number. Because for me it was surprisingly fast, and even what doesn't mean, because in Spring there's also no deployment, so it's comparable. Okay, and then this is comparable because the startup time is Quarkus is hopefully faster than Spring Boot. This is what I know on server side. This is a lot. It's like in Lambda is like what I heard. I know that some project I was asked to help some projects because its cold start were like 10 seconds, and with Quarkus this was not exactly the same application, but we rebuilt in the workshop and from scratch. With Quarkus, and it was like 3 seconds. So it was orders of magnitude faster, but it was absolutely not comparable because I built something from scratch. I had no idea what they did, but so it was not comparable, but they were happy with the result.
And I've just checked, actually, and I think I have told you completely incorrect things, which I think is because of the recent work. So I said that Quarkus was 20 or 30% slower to build, but I'm just looking at our latest numbers, and what I am seeing, one of them is 10 seconds to build and one of them is 13 seconds to build, but it's backwards. So at the moment now, for our fairly simple little CRUD application, Quarkus is 10 seconds to build. Sorry. I am completely incorrectly reading the chart.
Okay.
This is why you shouldn't look at numbers like live or okay. Yes. So what we see is that Quarkus is 10 seconds, Spring 4 is 6 seconds, and Spring 3 is 5 seconds. So
it's twice
20 or 30. So
twice. And is this Quarkus dev or Quarkus package?
This is Quarkus package.
Okay, this is but this is production deployment.
Yeah, exactly.
This is what you will do maybe before you push to pipeline, and this is what pipeline does.
Yeah, exactly. And so, like, I think the speed of your pipeline is the thing that you want to optimize last compared to everything else.
Yeah. Okay, so Spring Boot, so we can say in my podcast, because Spring Boot is highly religious topic. So, and we find out something good. Spring is twice as fast as Quarkus for a production deployment.
Just for the build duration.
Yeah, but build duration is build duration, production build duration, because Quarkus dev is incredibly fast. It builds behind the scenes, and this is very fast. It's like, I don't know, milliseconds to seconds.
Yeah. And then in terms of your throughput, for that slightly longer build duration, you get 3 times the throughput. And then pretty much 3 times the boot time as well, or, a third of the boot time. So Quarkus is booting in 2.8 seconds and Spring is booting in 6.5 seconds.
I found another interesting a feature of Quarkus, which I didn't thought before. And what I did recently is I had to go through cybersecurity certification. And this is 27001. And they ask various questions and so forth. And what's interesting by Quarkus is, because it's static, it is per default way better for the security. It is one of the questions. So no dynamic behavior. Then the tree shaking is also great, because it doesn't start beans which are not used, so it just shuts them down. So there are lots of security features for Quarkus, which are interesting for a real advantage. But for the certification was particularly great, because there's one more point to justify and not justify, just to say we use Quarkus because, and there was like, no, forgot about it, 4 to 5 features which were relevant. So this is like Annex is the name, and there are lots of like how to call it, like catalog of facts and Quarkus with Java. Also the microprofile thing was cool, because we say, okay, there's only for the SBOM. Built in SBOM, With that is also one of the questions. And with the SBOM was created JSON with all the dependencies. And because we only use smallRye, I could say, okay, with the smallRye dependencies, the same dependency OpenLiberty and all the others are using. We are no unique snowflake. It's like, the dependencies are common across multiple runtimes. Yes. So there were lots of advantages which I never thought before. And with the SBOM was great, because this was just one, I think, Maven package SBOM or something like this, and you got the SBOM. So there was not even a plugin required or extension in the recent Quarkus.
Yeah, and that SBOM was a lot of work, actually.
Cyclone DX, right? Cyclone DX.
Yeah. But the because of how Quarkus builds, we have a lot of stuff that is on the build time class path that isn't on the runtime class path. And of course, that's a security benefit. But then it means, in terms of understanding what's actually in the deployed artifact, you can't just look at the runtime class path. You have to look at both, and then sort of figure out, well, this is there at the deployed time, but it's, it doesn't affect the runtime, so I'm going to exclude it from the SBOM. And in the other direction as well, like, this is used in order to do the booting in advance and the reflection in advance and that kind of thing. So I really have to consider it in my SBOM. So it was distinctly non-trivial to get that SBOM, just on the Quarkus side, to sort of work out, well, what are the actual dependencies? What actually needs to be in that bill of materials? So yeah, it was a big piece of work from my colleague Alexei, which I'm very glad it was him that did it and not me.
Okay, I won't cut it out, so it would go live, the statement. Okay, what's interesting, Quarkus is also what happens more and more recent times. So at the beginning, it was more like micro-profile runtime, a very good one. But now you manage to do the following. Yes, you are not depending on third party, but you can add added value without being depending too much on Quarkus. 2 examples. One is the Grafana stuff with observability. It is absolutely, I get, in the DevTools, I can launch the LGTM stack, but there is almost no there is no impact on my software. I'm just still depending on hotel and nothing proprietary. And the SBOM is even better because there's absolutely no dependency on anything. It's just a command, and I get SBOM for free. It's like, the how to call it, DevOps convenience, maybe what Quarkus gets more and more, which is good to have, because this is the differentiator right now, right?
Yeah, definitely.
Back to energy and performance. So what I always ask myself, and the job runner, the Mr. Dehusa with the job runner did similar thing, is the old machine learning stuff, right? So now it's maybe too late because there's too much brute force going on. But at the beginning, I always ask myself, why they not train the model where the sun shines, Because if there is a sun, someone in California, it shines all the time. In Europe, we have blasts of sun and then nothing happens. So actually, we could use the overcapacity, to train models or do whatever, run jobs or whatever. This is what Kubernetes was about. So dynamic behavior. And it seems like, to me, Kubernetes is just nothing else than virtual machine, which runs all the time. So zero advantages of Kubernetes are used. And for that, Kubernetes or serverless would be just perfect to do whatever is optional in the burst of sun or wind or whatever, right?
Yeah, completely. And it's called carbon-aware dispatching. And it's something that people have been talking about for ages. And I'm not aware yet of anything that has actually made it to production in a ubiquitous way for that. Because you're exactly right. There's a lot of data APIs that are available to support that. So there's a service called Electricity Maps, and I think it's like electricitymaps.com. And it's actually really fun to just go look at that website, because they give you sort of a map of the world, and then you can see what the energy mix is for each grid. But that's just the sort of the free service is the website, but then you can also pay for their API, and it will give you the electricity mix at each time, because there's a couple of things that might influence the electricity mix. So one is, as you say, whether the sun is shining. But if the grid has a lot of wind power in it, then actually sometimes that's more available at night because it ends up windier at night, or it's more available in miserable weather because it's windier. So again, you sort of need to, it's one of those things where you kind of need to draw on a proper source of data, because our intuition about when there's the most green electricity isn't always correct. And then the sort of the other thing is the demand. So if the demand is high, like, the sort of the classic one is if everybody's watching TV and then they all go to make tea at the break and put the kettle on, then there'll be a spike. So you want to kind of avoid running your batch processing at that time. But you can sort of combine all of those things, and then you can input that into your scheduler, you can input that into your dispatching logic, and then you can move the workloads. And it's the sort of the whole promise of cloud native was that you could do exactly that you could quiesce your workload and move it somewhere else, and it wasn't going to cause a catastrophe.
Yeah, and what I saw in Kubernetes, my clients are doing, they do basically nothing. So they order the largest possible cluster, and it stays static for years. So there's actually no difference to 20 years ago. And what I will assume, what OpenShift did, I think 10 years ago, before Corona, I look at this, you could incorporate business metrics so that the load balancer listens, and dispatches the load depending what your application is doing, not from JVM perspective, rather than from business perspective. And you could extend that with, I don't know, energy, because business metrics costs are business, right? So you could expose, look, if you call me, I will cost you €1 and the other one 50 cents, go there. Or and maybe understandable, because there is no on premise. There is actually, if the Kubernetes runs is a little bit dangerous, even to be too dynamic, because the data centers are constrained. There's not like hyperscalers. They only have certain compute capacity, and it's not too dynamic. But in the cloud, you could absolutely do this, and if not with Kubernetes, with serverless, because if even AWS in Frankfurt, they have 3 data centers. There's at least 3. There's availability zones. And an availability zone, per definition, has to be roughly 100 kilometers apart from the other one. So you have one region, 3 availability zones, and every availability zone has multiple data centers, but they have to be far away apart of each other to survive a catastrophic event. So, and in Germany, if in one place is no sun, it is likely then the other place have sun. I mean,
yes.
more or less, you could even have like energy-based, complete transparent load balancing in Frankfurt. And not for everything, just for the serverless functions, which run for a few seconds or minutes and then get started on another server anyway. So this would be the low hanging fruit, I would say.
Yes.
And with the machine learning, I don't understand completely, because at the beginning you could absolutely do this. Now they try, they build a huge data center. So I think now it's harder. But at the beginning, it would be a perfect business case. And I never heard about that. So no one talks about that.
Yeah, I sometimes think what gets measured gets optimized. And so a lot of organizations, they just don't have the visibility of their energy metrics. And it's kind of hard to measure. So, there's a reason that information isn't there. And then because of that, it just doesn't get thought about. And there's so many things that you could do so trivially. So as you say, the sort of the carbon aware dispatching is one. Another one is, going back to what I was saying at the beginning, often there's something that will run on a really predictable schedule. So I visited one client and they had a batch job and they just ran it every weekend. But the servers that were running it were up 24/7.
Yeah, sure.
And, they don't need to be. They could be shut down, and that capacity could be used for something else.
From Monday to Friday was warm up phase of the so and then. Yeah. What's about the numbers? So you can you just reveal some numbers? So energy efficiency, Quarkus versus whatever, or what do you have right now? We will put it to the show notes, the entire study for the listeners. But right now, can you reveal some basic findings of Quarkus?
So what we've got is the slightly older data that you mentioned at the beginning. So if we can add it to the show notes, but it's sort of order of magnitude half the energy consumption with Quarkus. So three times the throughput and half the energy consumption.
You only compare to Spring Boot or also to others?
We only compare to Spring Boot just because that's the sort of the incumbent.
But JBoss would be similar, right? I think.
Yeah.
Maybe this will be interesting.
Yeah, I don't know I don't think it's something that we've ever measured. And in a sense, it's it's sort of in a business sense, it's not something that we sort of need to know.
Exactly. Yes. It was. But from the technical perspective, Quarkus optimizes during the build, and JBoss not that much, and Spring Boot I think also not that much, and that's the difference. And you're right. It would be interesting to know, but what I can tell you is people like Quarkus more than JBoss, and this is my observation. So from the how to call it, it would be not smart, to spend too much time investigating JBoss from the cost perspective, but it would be just interesting to me to have because I think from the outside looks like, they don't like Spring Boot, and this is why they compare against Spring Boot, and they don't compare against OpenLiberty or JBoss. This is this would be interesting just to know, and I would assume that maybe Spring Boot is a little bit more efficient than JBoss. If it isn't, then the entire discussion the last 10 years was pointless anyway, because I heard all the time, Java is bloated and Spring is lean. If this is no more true, then it was completely wrong. But I hope that Spring is faster than JBoss and Quarkus is faster than all of them, right?
Yeah, so I don't know about the Spring JBoss comparison. I haven't seen those numbers at all, and it's not something that we've measured. But I do know one thing that we are measuring is, so, for us, there's not a lot of value in comparing Quarkus to JBoss, but there is a lot of value in optimizing JBoss, and we are working on that. So my colleague Jeff Mesnell is sort of leading an effort on the JBoss side to look at the energy efficiency of JBoss and find the things that can be optimized. And I've got another colleague, Dinakar, and what he's looking at is he leads the Cruise Auto Tune project. And so what they can do there is they can use hyperparameter optimization to find the optimum set of parameters that meet some constraint. And so they're looking for the set of parameters that would allow you to run JBoss with the same throughput, but a lower energy consumption. And so they're sort of, cranking away in the lab doing that. So there's definitely, something that the JBoss team are interested in. And they are sort of looking at their optimizations, which is, it's the classic thing, isn't it? Of like, don't compare yourself to others, look at what you can do for yourself. And, that's exactly what they're doing. And that's also, what we're doing in Quarkus as well, as we, we spend a lot of time looking at
this. Is also even on the earliest before, ChatGPT on the podcast, we had some episodes about machine learning and AI before ChatGPT. And I was always interested because JVM or application servers are the perfect case, because we have a certain set of parameters and we can measure the performance. So what you could do, you can change one parameter and automate the entire thing and change measure, and then add, all the parameters to kind of machine learning stuff, whatever it is. And I think back then this was like H2 is a Java machine learning library. So we talk about that, how to do this, and this will be possible. So I think this is interesting work with the auto-tune, what you said, because it is interesting and it will work, but this is where AI is perfect, actually.
Yeah, and the JVM parameters, it's a really sort of tricky thing. And I think it's a problem that we haven't quite solved despite trying really hard, because you have this tension, this sort of three-way tension. So on the one hand, it's a classic internet question that, people will go to Stack Overflow or something and say, well, what is the optimum set of parameters for the JVM? And then someone else will come back and say, well, you can't define an optimum set other than the default. And everybody really hopes that there's this sort of go faster command that they can cut and paste. And Ben Evans, when he used to work at I've just blanked on, but he used to work at one of the companies that would, sort of take everybody's JVM parameters as part of the logging and observability. And when
this was the company with before they sold it to Microsoft, right? This was the
so he used to work at JClarity, but that's not
JClarity. Okay.
Yeah, so this was after JClarity, but what they found, because they had sort of this enormous market share. So they, had like 30% of the command lines in the world that they could analyze. And they saw some ridiculous proportion, like 10% of those enormous number of command lines had the same typo in them. So it was, because, normally you always set a power of 2. So, but instead of 6048 or whatever, it was 604. There was a digit missing, and the number made no sense. And if you looked at it with human eyes, you'd say, well, that number makes no sense. But it had been cut and pasted and just sort of replicated across the internet like a virus, even though this parameter obviously made no sense. But that's exactly, it's this sort of folk wisdom is the way that most people set parameters. So then you say, okay, well, this is stupid. We have to be able to do better. And I remember like 20 years ago, we had this big initiative that was autonomics for the tuning. So exactly that, of like, instead of having people to sort of micro tune every knob, let's have them tell us at a high level what they want and let's do it for them. But even that turns out to be really hard, which is why people are still sort of looking for the parameters and trying to set it through folk wisdom, because if we try and do this measurement in advance, that will get us part of the way, but we risk overfitting. And even with machine learning, if you're not doing it in the actual runtime environment, you risk overfitting. And so then what you need that logic in the system at runtime to be able to optimize. And of course, optimizing at runtime in a dynamic way is a really hard problem.
Yeah. You are the typo. So I remember the anecdote or what happened to me in the early 2000s. I worked for an insurance company, and so the project was almost ready to go to production. So I was told to deploy the software. It was WebSphere Classic on Sunfire, the big machine, 18K, so the largest one. And And I wanted to do that. It's like, no, you're not allowed because we have a WebSphere expert that do nothing else than deploying the software. So, okay, what I can do, you have to call him. So I call him, and it's like, hey, and he said, okay, what should I do? It's like, I deploy my software. This is I think it was EAR back then. Just go ahead. He said, no, I have to tell him the parameters. It's like, okay. And I remember back then you have, to tell the class path. So I had minus class path and then said, okay, then slash and so forth. And I said, now it's up. It's like, it's crazy. In 1 second, up? And say yes. And so we did it 10 times and it was not available. So next time I went to train and traveled 200 kilometers to Stuttgart and met him. And it turned out he had no idea about Java. What he did is he wrote minus class path without blank, without blank, because I didn't dictate it via phone, blank, so minus class path, and he didn't knew that. So minus class path without blank, this was the WebSphere expert, and slash. And then if you did this with WebSphere, it just stopped. So nothing happened, and he assumed everything is green and we are in production, nothing happened. And I told him, look, in Java, there has to be blank. And I said, okay. And then he told me, maybe it's a good idea to get Java training. It's like, yeah, if you are a WebSphere expert, I think it would be an excellent idea, right? So I was like, this is incredible. 1 day lost, complete wasted. So this is also typos, This is, I immediately remember WebSphere and class path. So similar. Yeah, this was nice. But this was 20 years ago. So why Quarkus is faster?
So there's, we've covered some of it. So that I think the two big pieces are that reactive core and building on Vertex, and so then that gives you the scalability and the efficiency. And then the other part is the building in advance, or when they were originally sort of conceiving of Quarkus, one of the problems that they were trying to solve was, could we make a Hibernate that would boot in advance? Because there's so much work that happens on startup. But I think one of the sort of the interesting and subtle things is going back to what I was saying before about used to talk a lot about our startup time and our memory, but we didn't talk a lot about our throughput. And so you would think getting rid of the reflection and doing that work to sort of move stuff to build time would be all about the startup, and that's what it would impact. And of course it does impact the startup, but it also affects the throughput. And so some of that is sort of obvious. If stuff like, if the reflection is going to happen all the way through on runtime, it would affect the throughput. But some of it is more subtle as well. So for example, when the JVM calls a method, if that method's on an interface, and if you have weirdly more than two rather than more than one possible implementation of that interface on the class path, the JVM will do something called megamorphic dispatching, which is that it has to kind of consider each possible target and then decide if that's the correct target. Whereas if you only have one or two, and I don't understand why it works for two, because it seems like
I also don't understand. One would be obvious, like functional interface, right?
So the two thing I don't understand.
Yeah.
It's so counterintuitive to me that it's possible I have that wrong. But I think I did double check when, when my colleague Sana Greenavera, you explained it to me. I was like, So if you have a very small number of possible implementations, then it does something called monomorphic dispatching, which is fast. So just all the way through, it just sort of ripples through and trickles down and affects the runtime behavior in a way that makes it faster.
This is what Quarkus does. It tries to... Yeah, you cannot do this without Quarkus. So it's like,
Exactly. It's the tree shaking, it's the doing more at build time. And then that just has this sort of knock-on effect to just remove a whole bunch of friction at runtime.
What you could do actually, but this is advanced stuff, but it should work. But you are aware of Project Leiden, right?
Yes.
But what you could do, you could similar stuff on business level. You could say, okay, I run the application, and then I know I only need 3 connections or whatever, and you could in advance, hard code all the business optimizations or not infrastructural optimizations, like connection pool size or whatever, into the bytecode, so it runs for the application perfectly. You know what I mean? It would be a bit dangerous because not visible, but it could be an interesting part. And, mixed with a little bit of AI, you could also maybe find, some more shortcuts, what you said, with two methods on an interface. And maybe you could say, okay, in this particular case, we don't need interceptors because they are never used. So we can just go straight, or there are no transactions. So you can start transactions somewhere else. So you could actually do more advanced stuff just by understanding what the client would like to have and optimize the bytecode behind the scenes. This is dangerous because then if something breaks, it's your fault, right? Because the client says, but just from the technical perspective, it should be possible, right?
Yeah, and we do some of that with Quarkus. So we have a distinction between build time configuration and runtime configuration. So build time configuration, it's, you're free to set it when you compile, but then after that it's locked. And as much as possible.
Exactly. This was also for the ISO 27001.
Yeah.
This big impression, because some configuration we can hard code at build time and there is no way to change it. And I showed them, build, if you have a config property, you can see there is an annotation like build on, you know what I mean? There's one annotation, build something. Yeah. And what happens then is the Quarkus hard codes the value into the bytecode, so it's not possible to replace it on startup time or whatever.
Yeah, and as you say, that gives a security benefit, and then it also gives the performance benefit. And so often, the reason that we haven't been doing this is just habit of, like, 20 years ago we wanted to be, defer every decision to runtime, but that just doesn't make sense when you have a CI/CD pipeline, because if you want to change the way in which your application is deployed, you're almost certainly going to run it through the CI/CD pipeline again.
Always. I would say 12 factors or whatever. We could assume it has to happen, right?
Yeah.
Pretty cool. So, but this config at build time, there's one specific annotation in Quarkus where you put on your config properties. You cannot change them later, which is very important for security, because you could say, okay, this deployment is production and you cannot change it. So you cannot restart and override it with environment variable. And this also made a big impression on the ISO auditors. Okay, so one question I wanted to ask you. So we have the performance, we had tree shaking, and I think we covered performance and energy efficiency pretty well, right?
Yeah. One thing I want to go back to, actually, because it's really interesting, and the reason it's interesting is it's counterintuitive and doesn't totally make sense, is the serverless aspect. Because there's a couple of things with serverless where your assumptions about what's fastest and your assumptions about what's most energy efficient, I mean, when I say you, I mean everybody's, don't quite match up. And it can catch people out. And I always want a world where, everything is simple and easy. And instead of doing the really complicated measurements, you can just look at what's easy to measure and make correct decisions based on that. With serverless, sometimes that doesn't work. So it used to be, for example, that in the very early days of serverless, the cold start problem was really terrible. And the way that Amazon fixed the cold start problem is that they would keep your application up all of the time. They just wouldn't bill you for it. And so that means that if you would look at your bill and assume that your bill was sort of correlated to how much energy you were using, which in general is a reasonable proxy, you would get completely the wrong answer because your application was actually, not at all elastic. It was up all the time. It was just sort of, your visibility of it was changed. So that was something that I think, that's now much better and it's changed, but there is still a higher overhead with serverless than with just sort of, deploying something and keeping it up all the time, which is completely a worthwhile trade-off if your application isn't up very much. But if your application is up a lot, then maybe that trade-off starts to swing in the other direction. But another thing that catches a lot of people out, which again I think has to do with the cold starts and how the serverless frameworks, which are quite complex, interact with the runtime. And it comes back a little bit as well to well, why would anyone ever recommend to use, sort of a heavy Java framework with a serverless architecture, is that sometimes the way it depends by cloud provider, but with some of the cloud providers, if you use GraalVM to compile your native binary and you have something that starts in 10 milliseconds and it's amazing, and you deploy it to serverless, and then you're seeing that it's actually taking like a really long time to start, and then you do the experiment and you just take your normal Quarkus application that hasn't been deployed to a GraalVM binary, and it's actually starting faster in serverless. And it's because that native binary is such a black box to the serverless framework that it can't optimize it at all. Whereas when you have a Java application, it really understands quite well how to optimize it, and it will use a different scaffolding and skeleton underneath, and it actually comes up faster. So it's one of those annoying things where, your mileage may vary, and you actually you can't just go from the startup times that you measure on your machine and assume that's what you're going to see in the cloud with serverless. You actually have to measure it with your cloud provider, and it may be that JVM is better for serverless than native, even though that is completely not intuitive.
This session will be a little bit longer because now I have also some ideas. So you are absolutely right. So I'm not aware. So I started hardcore serverless beginning of Corona time, because we are forced to go to the cloud in many projects. And I thought, okay, if we go to the cloud, then we will really use the cloud and not just start a VM in the cloud and, tell everybody we are cloud native. So we use serverless. And back then was no more the case. So the cold start of Quarkus was 3 seconds usually. So like typical microprofile application with all the dependencies, health check, fault tolerance, config, and so forth, 3 seconds or less. But what AWS did is that at the beginning, they use more cores until the application was up, and then you paid for the remaining cores. So this was my knowledge, is like Corona 6 years ago or something. Since then, it didn't change. What you could do in the cloud is you could do provisioned concurrency. So you pay extra, and then it's warm all the time. So there is no cold starts. You pay maybe for Quarkus with 1 core and 2 gigs of RAM, $14 a month. This would cost you to be warm all the time. The surprising thing is, if you have lots of traffic, you can save money with this, because if you have provision concurrency, every call is cheaper than without provision concurrency. So in high volume applications, you can save money with that. Now, GraalVM is interesting. So, I have to admit, it's not the main reason that we would like to save energy with Quarkus in the cloud. It's more like we would like to save money. And this always happens for enterprise applications. Because in enterprise, if you think about this, the enterprises are operational in Germany from 9 to 5. Night, nothing happens.
Yeah.
So it means my measurements, Quarkus, 2 transactions per second, 2 gigs of RAM, 1 core, and you will pay $10 to $14 a month. But 2 transactions per second, 24/7 is a lot. So what happens is, a day you can have peaks and more, and night nothing happens. So usually most enterprise applications do pay nothing. In my case, because they never reach this threshold, and this is highly available because it is like the lambdas are spread across servers, and Quarkus does one amazing thing. So we discuss this the entire session here. What Quarkus does is it consumes the cloud event from AWS and calls the regular JAX-RS endpoint without reflection, I assume, because it's extension. So it means it's crazy fast at parsing JSON, and for the application developers, there is no difference to regular microprofile application.
Nice.
So it means with Quarkus, you are independent of AWS. And this is, of course, best of both worlds. So you can program as you always did. So my Lambda project looks like museum technology, from 2008, Java E, the same code, but it runs fast and is really cheap. So this is actually the interesting part only Quarkus can do right now. So this is the cool story. And there is also technology called SnapStart. And this is like Crack, but more, because the entire Lambda stack is stored and encrypted and distributed across the availability zones. So the next time the Quarkus is loaded from memory, and it starts maybe under a second. So this is way faster. But as I said, this is a regular microprofile Quarkus application. If you look at the code, it looks like Java EE microprofile. The only difference is there is one request a time. This is truly cloud native, so there are no threads involved. So request scope doesn't make any sense. So everything is application scoped then. So it means the Quarkus extension is the magic, which consumes the AWS event and calls behind the scenes the JAX-RS event. And Quarkus provides, like, I think it's called streamable invocation handler, something like this. And this is what AWS sees, and it dispatches the call to hundreds of endpoints. The last part of GraalVM, I never did it in production, not because of performance. If you just go with Quarkus and with the JVM, Microsoft OpenJDK or AWS Corretto, what you get is they will patch the JVM for you. But the worry is, if I would use GraalVM, I have to build the image in my pipeline, and I have to track, the security issues or whatever, and patch by myself. So it's not truly serverless, because serverless means we don't care about the infrastructure. This is why this is a little bit longer. But and what interesting on my clients, we turn on now CO2 consumption. The cool story is because the cloud providers are calling the Lambdas, and they know what hardware is behind. They get the CO2 consumption on the invoice.
Ah, nice.
This is really nice, because I get lots of questions, and we get it for free.
Yeah, and as it's that thing of, once the cloud providers start providing the data, then you have the information that you can use to make your optimization decisions.
And on the other hand, we have lots of clients with OpenShift on premise, and this is completely different. There's always GraalVM. So we have request scope. This is like, this I have right now is really two opposite architectures. Serverless in the cloud is completely different than, for instance, it doesn't make any sense to run Postgres in the cloud, because you have to set up Postgres by yourself. So you use some already, Cosmos DB or DynamoDB, whatever is there. But on premise, I only use open source. On premise, we use Kafka, Postgres, just open source. In the serverless public cloud, we never use Kafka. We never use Postgres. We always use proprietary technology, because we don't have to care about that. We don't have to run it.
Yeah, that's really interesting.
Yeah. I have to reinvite you back to talk about class loaders, the developer tools, and all the problems you have internally, if you like. So this is an interesting project to do with, you are all over the place on GitHub. So we have to talk about your commits.
Yes, that sounds like an management appraisal. Ollie, we have to talk about your commits this year.
Yeah, absolutely. And then you get your raise,
Yeah.
Yeah, if you like, welcome back, and thank you. And where people can find you? We will put your work to the show notes. You can also mention how to find it and so forth.
Yep. So you can find me at hollycummins.com. And you can also find me on LinkedIn and Blue Sky and GitHub. So on all of those, I'm Holly Cummins.
Holly Cummins in Java, or you are unique enough that if it's...
So it's just Holly Cummins. Yeah.
Pretty cool. Yeah. And what was the title? Green Java, right?
So it's writing greener Java applications.
Greener. Okay.
Yeah.
Very good. Thank you, and see you soon.
Lovely. Thank you. See you.